Today we're going to talk about finding the area of composite figures by decomposing into rectangles and triangles. So let's take a look at this composite figure right here. What do you notice? Well, first of all, I notice that this right here, if I were to split this right here, that this would be a rectangle. So I'm going to go ahead and grab a line here, and I want to go ahead and decompose that. So now what I have is a rectangle and a triangle. Well, what do we do to find area of a rectangle? So we've looked at area of rectangles on grids with our triangle conversations. And so this one is also on a grid, but you'll notice that you can't see each individual square unit because this has been filled. So how can we figure out the area if we can't just count the number of square units inside the rectangle? Well, remember we talked about another thing that we could do. We could count the number of square units in one row and multiply by the number of rows. So I could look at this grid here and come down here and do some counting here. 1 square unit, 2 square units, 3 square units, 4 square units, 5 square units, 6 square units. There's 6 square units in one row, and there are 1, 2, 3 rows. So I'm going to go ahead and label just so we can keep track of what we've said. So there are 6 square units in a row, and there are 3 rows. So we could look at 6, 12, 18, or 3 times 6 is 18. So this rectangle has an area of 18 square units. So let's take a look at the triangle now. Well, remember the strategies we talked about when working with triangles is we've thought about those as what would the rectangle look like if we were to draw a rectangle, compose a rectangle around this triangle? What would that look like? And so we're going to go ahead and do that here. All right, so now I have a rectangle. It's been composed around this triangle, and we know how to find the area of a rectangle. We can count the number of square units in one row and multiply by the number of rows. So let's try that. 1, 2, 3. There's 3 square units in a row, and there are 1, 2, 3 rows. So let's go ahead and label that. So we have 3 units in each row, and we have 3 rows. So 3 times 3, 3, 6, 9. So the area of this rectangle is 9. Now, what do you notice about the area of the triangle? Well, the triangle takes up exactly half of this rectangle. And as you'll notice, this particular rectangle is a square with all equal side lengths. So anyways, we can divide the area of the rectangle in half because the triangle only has half the area of the rectangle, or the square in this instance. So 9 square units. Let's go ahead and write all this out. 3 times 3 equals 9. And that's 9 units squared in this case. And because we're looking at half the area, we're going to take 9 units squared, and we're going to divide that by 2. And 9 units squared divided by 2 is 4.5 units squared. So that the area of this triangle is 4.5 units squared. So how are we going to find area of the entire figure? Well, we have the area of this rectangle, which is 18 units squared, and the area of this triangle, which is 4.5 units squared. So we're going to add those together. 18 plus 4.5. So I know that 18 plus 4 is 22, plus the half. The area of this composite figure is 22.5 units squared. So remember, when you're working on area of composite figures, you can decompose those into rectangles and triangles, find the area of the rectangles and then triangles, and then add them together to find the total area of the composite figure.